Hello, graphing. For some people, when you say graphing, they get panicky. They shouldn't. There's nothing difficult about what we're going to do, but there's a lot of it. So each individual thing that we're going to do is extremely easy. It's just that it starts to build up over time. So let's get started. And for example, if we draw a number line, thus, and we draw another number line, just like that, at right angles, perpendicular, orthogonal to the first number line. Those are two number lines. And we can think of this as the east-west and the north-south on a map. This is called the x-axis. By convention, by tradition, we just call it the x-axis. And this is the y-axis. It's just what we call them. But you don't have to call them that. And sometimes, for example, in physics or elsewhere, economics, this might be the time axis, we might call it the t-axis. And this might be the profit of a company, so maybe this is the p-axis, or the velocity of an object. This might be the v-axis. Nonetheless, mostly in this class, we're going to call this the x-axis and the y-axis. That's just a matter of remembering that that's what those things are called. This point here is called the origin. That's just what it's called. Now that's an easy thing. There's really nothing to understand. It's just, we just call this point the origin. But that's another thing that gets thrown in there. Now, let's suppose that we march out 1, 2, 3 units in this direction, maybe east, but in this direction, 3 units to the east, and we go up 2 units, okay, north or up, or however you want to call it, but 2 units up. We're going to call this the point 3, 2, and we're going to write it like this. And I'm sure you've done this sort of thing before, and this is just by convention. When I write it like this is always assumed to be the x-coordinate, and that's assumed to be the y-coordinate. This whole thing altogether is called an ordered pair. It's also called point. So I may say ordered pair because I'm thinking of this, because it's a pair of numbers and they're ordered. X comes first, y comes second. That's a point for the obvious reason. Well, you're looking at it's a point. When I make this mark right here, I've plotted the point. Now already we've got the x-axis, the y-axis. Oh, I forgot to mention, this whole thing here, this whole object is called the xy plane, or the xy coordinate plane, or rectangular coordinate system, or just a plane, or Euclidean two-space. I can't help it. There's a lot of different names for it. I may not even refer to it, or I may just say coordinate system. There are other coordinate systems, but this is the only one we're going to be using. And this is a point. It's also an ordered pair. I've plotted the point, x-axis, y-axis. This is the x-coordinate, that's the y-coordinate. Each one of these things is just a matter of knowing what the word means, but it's getting to be a lot of things already. Now, a guy named Rene Descartes came up with this. It really doesn't seem like much, and I remember hearing that this was a really great, significant achievement. And honestly, it is, but it probably won't even be clear by the end of this course why this is a very deep and profound and consequential thing that this guy, Rene Descartes, came up with. He also, and I won't try to botch the Latin, but he came up with the expression, I think, therefore I am, and more on that another day, maybe the philosophy behind that, which is interesting, more interesting than you think. Now, let me write down something. Y equals 2x plus 3. That's an equation. It's not a graph. It's not a picture. It's an equation. But there's a connection between the equation and a graph, and also a graph and its equation. And again, I'm sure most of you have done this before, but I want to just do this from the ground floor up. Pick a number, any number. You pick 0. Good choice. Why 0? It's easy. It's a fantastic number. It's easy to deal with. Let's suppose we make x. Let me go ahead and make a chart like this, because I'm sure you're all pretty used to seeing this sort of thing. And this is usually referred to as an XY table of values, or a table of values. I won't call it anything, honestly, but it's a way of saying, hey, suppose we want to make x 0. What would y have to be? So put a 0 in here. 2 times 0 is 0, plus 3 is 3. so y is 3. And what we've just done is we have obtained a point, because a point is the same thing as an ordered pair. An ordered pair which is a solution for this equation, and we can graph this point. How do we graph it? Well, x is 0, y is 3. X is 0, what does that mean? Don't go to the left or the right on the x-axis, because that's determined by what the x-coordinate is. And then y is 3, so we'll go up 3 on the y-axis. 1, 2, 3. And I'll put a little dot right there. Now, by convention or tradition, we usually somewhere nearby here label it. Like on your house or apartment, somewhere in the vicinity you have your apartment or house number. Could be on the mailbox, could be on the door, could be near the door, but it should, be nearby. So let's say I'm going to call this the 0.03. I'm not going to call it, but it is the 0.03. I could put a little arrow here if I want. You make the call on that. If it's clear that this ordered pair belongs to that point, I'd skip the arrow, but if not, put an arrow in. Is 1 point enough to make a graph? Absolutely not, because there could be an infinite number of graphs that run through that point. So let's pick another point. Why did I pick x equal 1? It's easy. I definitely want to stick with easy numbers right now. If I put a 1 in here for x, 1 times 2 is 2, plus 3 is 5, and so we get 5. So we get the point 1, comma 5. 1, 2, 3, 4, 5. We go up 5, and here's the point 1, comma 5. Now, I will tell you something. In this chapter here, everything we're graphing is a straight line. I haven't proved that. I haven't demonstrated that. I haven't even vaguely said why that's the case. But I'll just tell you right now that everything we're going to graph in chapter 3 is a straight line. Now, assuming that is true, assume for a minute that's true. If we're graphing a straight line, how many points would I need to make the drawing of a straight line? 2. Once you have 2 points, there's only one straight line that can go between them. So this is really all I need to plot. These are all the points I need to plot. Or this is a sufficient number of points to plot so that I can graph this line. And it would look like this. Now, I could have done another one. I could have thrown in a negative number just for fun. Let's say -1. Put a -1 in here. -1 times 2, -2 plus 3 is 1. So the point -1, so we go over here at 1. And I come up here and, well, my drawing is not fantastic. And I'm going to want to talk about using graphing software. Let me talk about it right now a little bit. I don't anymore worry about making particularly nice hand-drawn graphs. I don't want the graph to look too terrible, but in this case right here, it's maybe not fantastically to scale, because if here's -1 and 1, that point, it doesn't really seem like it's on the line, but here I'll just fudge it a little bit there. But when I want to make a really nice graph, I use graphing software, and I just use something free online, Desmos. And eventually we'll be using some of that, and I'll give you links and all that sort of thing. For right now, I would prefer if you would do this by hand, because it gives you a feeling or a better intuition about how these things work. Was it necessary to do more than 2 points? Absolutely not, unless you were feeling like maybe you made a mistake and you sort of wanted to verify that the straight line you were getting was correct. That's not too bad. That's it. Oh, wait a minute, there's always more when it comes to graphing. Whenever we're looking at a graph, we are going to be asking, or I'm going to be asking, or somebody's going to be asking you, what is the x-intercept and what is the y-intercept? So where does the graph cross the x-axis and where does the graph cross the y-axis? Well, how do you find where a graph crosses the y-axis? For any graph. For any graph. How do you find where the graph crosses the y-axis? Well, look at this point right here. It's not to the right, it's not to the left. So whatever this point is, x has to equal 0. So to find the y-intercept, you make x 0. You set x equal to 0. Now we've already done that, fine, put a 0 in there. And I have the y-intercept. What do I know about this point right here? Well, the one thing I know is it's not up or down. It's right on the x-axis. So the y-coordinate has got to be 0, because it's not up and it's not down. So how do you find the x-intercept? You set y equal to 0. So let me do that. Put a 0 in there. Now, given the fact, think about the last equations that we did, the last video that I did with equations, not inequality equations. This is a walk in the park. This is unbelievably easy compared to that sort of equation, which is good. That's nice. Nothing wrong with that. Let's go ahead and solve this for x. So subtract 3 and divide by 2. You get negative 3 halves, negative 1 1/2, but negative 3 halves. So this is negative 3 halves. One comment, I rarely, and almost never use mixed numbers. So yes, I'm going to leave it as negative 3 halves. Now maybe I'm thinking negative 1 1/2. Maybe I'm thinking that, but I'm going to write it as negative 3 halves. This is more or less, I mean, a complete, I mean, this is a complete, I don't know what a complete graph, that'd be an interesting idea to investigate is what constitutes a complete graph, but this is a complete graph of a line. There's really not much going on with lines. There's the picture of it, there's the x-intercept and the y-intercept, and there's one other thing, and I'm sure you've heard about that, and that's the slope of a line, which is a measure of how steep the line is. You know, is it relatively flat or really steep? Or maybe it tips this way, and there ought to be some way of indicating that. So let me erase this, and we'll talk about slope of line. That'll be it for this particular video. That's not it for chapter 3, but like I said, chapter 3, if you read the announcements, is not too bad of a chapter. I think for most people, if they don't have any preconceived notions of freaking out before they get graphing. And this is because it's graphing of straight lines. When we graph parabolas and hyperbolas and ellipses and other things, I honestly won't be saying it's easy. I mean, that's something you won't hear me say when we get to those. But for right now, this is relatively easy. Here's an XY coordinate system. And let's suppose we have a line, and the line looks like this. Let's say this is the point 1, 2, and up here, let's say this is the point, and I'm not really trying to make a particularly nice drawing here. Let's say up here, this is the point 4, 8. And I draw a straight line between these 2 points. How steep is that line? What would be a way to quantify, to measure how steep that straight line is? And there are really 2 obvious approaches. Oh, I guess there's a third. You could say, well, it's pretty steep. That's qualitative. That gives us the quality or our overall subjective impression of the line. Maybe think, wow, that would be really steep to walk up. You know, granted, it looks pretty darn steep. But that's not particularly useful for us to do mathematics with. Another idea might be to compare it with a horizontal line and look at that angle. And that is a very useful approach. But we're not going to be doing that in this course. When and if you work with trigonometry or calculus, yes, you'll be using that a lot. Physics, yes, a lot. But for this course, maybe this is good news. Nope. No angles. So we need another way of doing it. And here's the idea. Suppose you were walking. Wait a minute. You're walking up this hill from here to here. Would you be still happy at the top? I don't know. We'll frown up there. So you walk from here to here. What is your height? What is your initial height? And the initial height here is 2. Because the y-coordinate is 2. So we're 2 units up. What is the height here? The height is 8. 1, 2, 4, 8. So you've gone from a height of 2 to a height of 8. Well, you've increased your height by 6. And how far over have I gone? Well, here I started 1 unit over, and here I'm 4 units over. So I've proceeded horizontally 3 units. So I've gone up 6 units. I've gone up 6 and over 3. And we're going to declare, so you can't figure this out. We're actually going to make a definition, declare that the slope of a straight line shall be the rise over the run. How far up you go divided by how far over you go. So in this particular case right here, the slope is 6 divided by 3, otherwise known as 2. How did we get 6? Started at 2, ended at 8. Started at 2, ended at 8. How do we get 6? If you look in your mind, at your thoughts, you probably subtracted. Maybe not. Maybe you counted. Maybe you started at 2 and 1, 2, 3, 4, 5, 6 and got up there, which you might have. But let's just, for the fun of it, say you subtracted. So in this case right here, I would have taken 8 minus 2, and that would give me the rise. And similarly down here, we'd have 4 minus 1, and that would give us the run. So one way to write this is as follows. We can say the rise is y sub 2 minus y sub 1. Now, what the heck do I mean by that? These subscripts, they're called subscripts, they're little letters, and they're written just a little bit below, it's numerals, and they're written just a little bit below the letter. This y sub 2 means the second y coordinate, y sub 1 means the first y coordinate. And we'll divide this by x sub 2 minus x sub 1. Now, a nice thing is if you multiply this fraction top and bottom by negative 1, you should try that sometime. Do the distributive rule. You'll see that this is the same thing as y sub 1 minus y sub 2 and x sub 1 minus x sub 2. So what does that mean? It doesn't matter what order you subtract the x's and y's as long as you're consistent. So if you took 8 minus 2, you want to divide it by 4 minus 1. Or if you took 2 minus 8, divided by 1 minus 4. In fact, let me go ahead and do that. We took 2 minus 8 and divided it by 4 minus 1. That's negative 6 divided by negative 3, but a negative divided by negative is a positive, so you get the same answer. So you just need to be consistent in the order in which you're doing the subtractions. There are other ways to write this. And a pretty convenient one often is this. It looks like a triangle, and it's a capital Greek letter D. It's a delta, D-E-L-T-A. I mean, it's kind of weird because I'm spelling a Greek letter with our Roman alphabet, but hey, nonetheless, it's a capital Greek letter D. It's a delta. So delta Y, and that delta in science and engineering mathematics, it often refers to the change. So this just means the change. And you probably heard that a lot. And if you haven't, you will, because people use this in all kind of contexts. From Wall Street to Boeing to sociology, psychology to chemistry. You're going to see it all over the place in life. You just will. And this is delta x. And so this means the change in y divided by the change in x. It is very traditional to use the letter M to mean slope. That wasn't my choice, but I don't have a problem with it either. It's fantastic. It's great. So the slope is delta y divided by delta x. So sometimes you'll see it written like this. Sometimes you'll see it written like that. It's not too often people say rise over run, or write it. They might say it, but they won't write it too often. But that's what the slope is. So now, in just a very short amount of time, we've built up the idea of x-axis, y-axis, coordinate plane, origin, ordered pair, x-coordinate, y-coordinate. Point is the same thing as an ordered pair. At least initially, how do you graph a straight line? Slope, x and y intercepts. So again, each one of those things is pretty easy, pretty straightforward, but it's getting to be a lot of things to keep track of, to remember. And so it's as is with every chapter, but it's very important to practice the problems in chapter 3. They're not particularly difficult, so you may say, oh, I understand that. And you probably do, but you want to practice that so this becomes ingrained. So if somebody says slope, you say rise over run, or delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or if someone says x-intercept, you say, oh, set y 0, set y to 0. Y-intercept, oh, set x equal to 0. So these things become second nature and become quite easy. One final comment, and this is important. It's a little more abstract, but it does, it will contribute to your knowledge and your ability to do problems. What is the specific connection between an equation and its graph, or a graph and its equation? And the connection is this. Every point on the graph is a solution for its equation. And every solution for an equation is a point on the graph. So here, I'll just come up with another one here. Let's say we had 4x minus 3y equals, I'm just trying to think of some nice numbers right Maybe those numbers are too nice. Let me make this a 5. So equals 8. Now that's an equation and it's not a picture. The idea is if you took every solution for this equation. Now what is a solution for an equation like this with 2 variables? It would have to be an ordered pair. Well, it would have to be a pair of numbers, and you can make them ordered, but it would be a pair of numbers. Someone would have to tell you what x is, and someone would have to tell you what y is. So suppose I claim, or I say to you that this is a solution for this equation. Well, is it? If it is, we'd be allowed to put this, the x coordinate, in for x, and the y coordinate in for y, and we should get a true statement. So put a 4 in there, 5 times 4 is 20, put a 4 in there, 3 times 4 is 12, 20 minus 12 is 8, so check. This is a solution for this equation. So if I plot this, 1, 2, 3, 4, 1, 2, 3, 4, this point is part of the graph determined by that equation. So this point is part of the graph determined by the equation. Now these numbers I just chose randomly. I'm not supposed to, kind of share. This is behind the scenes, the making of. Let's suppose y is 0. Put a 0 in here. Anything times 0 is 0. So you get 5x equals 8, so 8/5. So suppose I said 8/5, comma 0. Is this point a solution for this equation? We'll go ahead and put a 0 in there. Put an 8/5 in there, and you'll see it is. So let me go ahead and graph this. X is 8/5. That's 1 3/5. So call it right about there. And the fact y is 0, we don't go up or down. So there's our y-intercept right there. I'll put a little arrow here. So this is the point 8/5, comma 0. How do you find the y-intercept? Set x equal to 0. You can chant that like a mantra. How do you find it? The x-intercept, set y equal to 0. How do you find the y-intercept? Set x equal to 0. But let's go ahead and find the y-intercept. We'll set x equal to 0. If I put a 0 in here, that's gone. Divide by -3, we get -8/3. So 0, comma -8/3. That's the solution for this equation. So this is on its graph. So 0, don't go left or right. -8/3, that's -2 2/3. So say 1, 2, 3, 4, 5, so on and so forth. So right about here. And like I said, you can label this anywhere. Here, I'll put the label down here, 0, comma -8/3. And if I were to continue on like this and graph an infinite number of points, this is what you would get. We get a nice straight line like this. So again, the connection between any equation and its graph is that every solution for the equation is a point on the graph, and every point on the graph is a solution for the equation. That's actually really important to keep in mind. Almost at all times, they're lurking around the back of your thoughts. Okay, so keep tuning in. I'm going to keep posting these videos. We can probably get chapter 3 done without too much trouble. Again, whenever you have questions, send me the question either via email or you can message here on Canvas. And you can also, if you want, snap a photo of your work. If you've worked a problem and you're stuck somewhere, snap a photo, send me the photo, and then I can see, how to fix the problem. All right, okay. That's enough for today.